Hi everyone, today we are going to see Schrodinger's wave equations in quantum mechanics. What are Schrödinger wave equations? Schrödinger wave equations describe the wave nature of the particle in mathematical form. This is the basic equation of motion of matter waves. There are two forms of Schrödinger wave equations: time-independent and time-dependent wave equation. Here, Schrödinger incorporated the expression of de Broglie's wavelength lambda is equal to h by mv in the classical wave equation for a moving particle, and he obtained a new wave equation called Schrödinger wave equation. Now we are going to see Schrödinger's time-independent wave equation. Consider a particle P moving with the wave velocity v in the x, y, z coordinates. The particle is moving, so it has a wave nature. The wave function psi represents the wave nature of the particle. The wave function psi, psi, is psi. It represents the wave nature of the moving particle. Consider the classical differential equation of the wave motion of the particle is given by dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, which is equal to 1 by v square dou square psi by dou t square, where v is called the wave velocity. Or simply, the above equation can also be written as del square psi is equal to 1 by v square dou square psi by dou t square, where del square is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square, which is called the Laplacian operator. The solution of equation 1 is psi is equal to psi naught e power minus I omega t. That is, the solution of the above equation is psi is equal to psi naught e power minus I omega t, where the wave function depends on x, y, z, the coordinates, the displacement of the particle with respect to time, and psi naught represents only the amplitude, and here there is a time factor e power minus I omega t. Now, Schrödinger derived time-independent wave equation from these two. We can see that there is a time factor involved here, dou square psi by dou t square. Here also we have a time factor, but the topic being Schrödinger's time-independent wave equation. So here dou square psi by dou t square is there in the first equation. We have psi here. So differentiating equation 2 with respect to time, we get dou psi by dou t is equal to, since psi naught represents only the amplitude, it is not differentiated, and e power minus I omega t is e power minus I omega t, and the coefficient of t is minus I omega, it is taken here. Just like e power 2x is differentiated as 2 e power 2x. Now it has been double differentiated. Here we get the dou square psi by dou t square. So again differentiating the above equation with respect to t. We get dou square psi by dou t square is equal to, we have psi naught again here, therefore psi naught e power minus I omega t. Already we have minus I omega here. Since it has been again differentiated, we have minus I omega. Consolidating, we get dou square psi by dou t square is equal to psi naught e power minus I omega t, minus minus becomes plus, I into I, we get I square is minus 1, therefore we get minus omega into omega, we get minus omega square. Then even we can simplify the above equation with replacing psi naught e power minus I omega t as psi. Here in equation 2 we get psi is equal to psi naught e power minus I omega t. Therefore here this is replaced by psi and we have minus omega square, which is equated with dou square psi by dou t square. Substituting equation 3 in equation 1, del square psi is equal to 1 by v square dou square psi by dou t square. So equation 1 becomes del square psi. We have del square psi is equal to 1 by v square. 1 by v square dou square psi by dou t square. Instead of that I am going to substitute this. So minus omega square psi. Now omega is the angular frequency. Frequency is inverse of time. Therefore here also we have time factor. Therefore this omega should be replaced by omega is equal to 2 pi nu. Nu frequency, we know that V is equal to nu lambda, or nu is equal to V by, that is here I am taking this as the same wave velocity, V by lambda. So omega is equal to 2 pi V by lambda. We have omega square here, therefore omega square is equal to 4 pi square V square by lambda square. Substituting omega square in the above equation, we get del square psi is equal to minus omega square should be replaced by this 4 pi square V square by lambda square. Already we have a V square here. I am writing it, and then psi. Psi is written here. So instead of omega square, I have replaced this omega square value. So I get V square get cancelled off, and I am consolidating this equation as del square psi plus, I am taking this towards LHS, 4 pi square by lambda square psi is equal to 0. Even you can take here also del square psi plus omega square by V square psi is equal to 0, and then you can substitute omega is equal to 2 pi nu. Then let this be equation number 3. Now, Schrödinger incorporated lambda is equal to h by mv. Therefore, I am going to replace lambda is equal to h by mv here. We get del square psi plus 4 pi square. Lambda is equal to h by mv. Lambda square is equal to h square divided by m square v square. And here in this equation we have 1 by lambda square. So we are reciprocating it. We get m square v square divided by h square. So instead of lambda square, I am going to substitute m square v square divided by h square, and psi is here. Psi is equal to 0. So psi is written here. Even we can replace this with h cross, where h cross is called as reduced Planck's constant. We know Planck's constant h. It is divided by 2 pi. It is called as reduced Planck's constant. Here we have 4 pi square by h square, that is h cross square is equal to h square by 4 pi square, and 1 by h cross square is equal to 4 pi square by h square. So substituting 1 by h cross square in the place of 4 pi square by h square, we get, so here this 1 by h cross square should be substituted here. So del square psi plus m square v square by h cross square psi is equal to 0. So this equation becomes this equation now. Again we have this velocity v square. So we know that velocity is displacement by time. Displacement of the particle by time. So we are going to replace this with energy of the particle. We know that total energy is equal to potential energy plus kinetic energy. I am going to name this equation as 4. Now we have m square v square here, especially the time factor is with v square, the wave velocity square. Now total energy is equal to potential energy plus kinetic energy. So let us take the total energy of the particle as E, capital E, and the potential energy of the particle as capital V. While writing, make a difference of wave velocity as V and potential energy as capital V. And kinetic energy is half m v square. Now rearranging these equations so that I need to get an expression for m square v square. So here E, I am taking this towards the other side, v minus v. E minus v is equal to half m v square. Then 2 is taken over the other side. 2 into E minus v is equal to mv square. But here in this equation we have m square v square. M square v square. So multiply the above equation with m on both the sides. We get 2m E minus v is equal to m square v square. Now substitute this m square v square as 2m e minus v in equation 4. So applying equation 5 in equation 4, we get del square psi plus m square v square should be replaced by 2m e minus v divided by h cross square psi is equal to 0. So this is equation number 6. So the above equation is known as Schrodinger's time independent wave equation. Time independent wave equation. Now it is with three-dimensional form, 3D form. Now if the expression or the Schrodinger's time independent wave equation in one-dimensional form is to be derived, then this should be replaced with, that is the three-dimensional operator should be replaced with d square psi by dx square, any one dimension. We know that x, y, z, 3 dimensions. Any one dimension should be taken. Usually we take x, d square psi by dx square plus 2m by h cross square e minus v psi is equal to 0. So this is Schrodinger's time independent wave equation for a particle in one dimensional form. This is for three-dimensional form. If the derivation is asked for a freely moving particle, derive Schrodinger's time independent wave equation for a freely moving particle. We know that for a free particle, it has enormous amount of kinetic energy, but the potential energy will be taken as 0. Potential energy is 0. Therefore, in the above equation 6 for 3 dimension and in 7 for 1 dimension, V should be taken as 0. So we get for 3 dimension for a freely moving particle, Schrodinger's time independent wave equation is del square psi plus 2m e by h cross square psi is equal to 0 because V potential energy is taken as 0. It is three-dimensional form of Schrodinger's time independent wave equation. For one-dimensional form, here the V should be, potential energy should be taken as 0. So we get d square psi by dx square plus 2m by h cross square into E psi is equal to 0. So this is Schrodinger's time independent wave equation. There are two forms, time independent and time dependent wave equation. We have taken time independent wave equation. We have taken a particle moving with a wave velocity v. Here Schrödinger incorporated de Broglie's wavelength h by mv, lambda is equal to h by mv in classical differential wave equation. And then the solution of the equation is taken, differentiated site-wise, replaced dou square psi by dou t square with minus omega square psi. Omega square is replaced by 4 pi square v square by lambda square, and then simplified it, consolidated, lambda is incorporated here, and then reduced Planck's constant is taken, and then still it has a time dependent factor called wave velocity. So it is replaced with the energy. The energy, total energy possessed by the particle is equal to potential energy plus kinetic energy, and then m square v square is replaced with 2m e minus v, and then we obtain Schrodinger's time independent wave equation in three-dimensional form. It can also be derived for one-dimensional form, where del square psi should be replaced by d square psi by dx square, where equation 6 and 7 can also be expressed for freely moving particle, where the potential energy is considered as 0. So the same 6 and 7 equation is written with v is equal to 0. Then we obtain Schrodinger's time independent wave equations in three-dimensional form and in one-dimensional form. Thank you.